Hello. So in this video I will be talking about solve multiple ways, which is going to be a category of videos where I show you multiple ways of solving a problem and multiple ways of proving what has been asked of you to prove. But before I begin, what I want you to know is that you should try yourself approaching and solving some questions multiple ways. Of course, in your untimed practice sessions. You do not have to solve one question multiple ways in your examinations, of course. So, say if you do try and solve a problem in multiple ways, you will learn a lot more mathematics than, say, you would if you didn't experiment with your approach. Now, as you solve a single problem multiple ways, not only will that solidify your understanding of the concepts, but after enough practice, you will start realizing that there exist long paths and short paths of solving a certain type of question. And of course, you would want to use the short path during your examinations to minimize time wastage and maximize your score, right? But to find these short paths, you first need to experiment and try solving a question multiple ways. You will recognize tricks and patterns which will help you solve a question quicker during your examinations or your timed practice sessions. So today I will go over this question from the Trigonometry Supplementary exercise of class 11th Mathematics NCERT. Now there are two ways that I know of solving this question. Let us talk about strategy number 1. Strategy number 1. So the supplementary exercise is full of questions that involve the lengths A, B, C of the triangle that I have drawn on the right hand side, or some expression on LHS and RHS. What these expressions can look like is something like this. You can have, say, A on the right hand side, you can have B plus C on the left hand side, you can have B minus C upon A, you can have A plus B upon C, stuff like that. You get the idea. Values like these or ratios like these are present in almost every question that has been given in the NCERT supplementary exercise. So in these questions, what I like to do is, before I begin solving the question, what I like to do is I like to gather these lengths B, C and A on just one side. Okay, so what I mean by that is, for instance, in this question I have B plus C on the LHS and I have A on the RHS. So I will take A to the left hand side, I will get B plus C upon A, and I will solve for B plus C upon A, and that will give me my answer. This is the trick that I like to use, and you can always do such manipulation in more questions. That is for you to try. So let me clean this up here. Okay, so the question asks me to prove this statement, and as I said, I will take this constant, this length A, to the left hand side, which gives me B plus C upon A as the ratios of lengths, and I will solve for B plus C upon A. So let us solve for B plus C upon A. Now the sine law states that sine A upon A, sine of angle A upon the length A, is equal to the sine of angle B upon the length B, which further equals to the sine of angle C upon the length C, and all of these bunch of values equal some constant K. Okay, this K can be anything, we don't know beforehand, but just for the sake of simplicity, this is 2. Okay, this is not a real value, I just made that up. So if sine A upon A is some constant which is 2, so A upon sine A is also going to be a constant, right? It becomes 1 by 2, which is again a constant, and I can write that as K again. Okay, so what this gives me essentially is I get the following expressions. let me use a different pen this time. I get a upon sine a equals k, which gives me a equals k times sine of angle a. Okay, and similarly I will get b equals k times sine of b, c equals k times sine of c. Okay, this comes from the sine law. Alright, and because a, b and c are these values, I can substitute these back into my expression, which is b plus c upon a. So let us do that. B equals k sine b, k sine of capital B. C is k sine of capital C, and a is k sine of capital A. Okay, now you can see that the k, this constant k, is common in the numerator, so I can take that out, and it is also present in the denominator, so these k's cancel out. Okay, now I'm left with sine b plus sine c in the numerator upon sine a. Now what is sine x plus sine y? That is 2 sine b plus c by 2 cos b minus c by 2, right? That's just how the identity is. So let us solve for that. Let us substitute this expression. And also, by the way, sine a can be decomposed to 2 sine a by 2 cos a by 2, right? You know why that is? Because sine of 2x equals 2 sine x cos x. The value of the angle gets halved once it comes to the right hand side. Okay, so that's why sine of x can be written as 2 sine x by 2 cos x by 2, which becomes a by 2 in this expression. So substituting for these expressions, I get sine 2 sine b plus c by 2 cos of b minus c by 2 upon 2 sine a by 2 cos a by 2. Okay, now at this point it's sort of wise to actually see what terms are present in the right hand side in your question, so you can figure out which terms to eliminate and which ones to not eliminate. Okay, so let me go back to the question here, and you can see on the left hand side we have cos of b plus c by 2, so we have to obtain that somehow, and on the right hand side we have cos of b minus c by 2, and we already have a cos of b minus c by 2 with us on the right hand side right here. Okay, so I'm gonna save that, and I'm gonna try and cancel the other terms out. Okay, now since we are talking about triangles, let me come back up here. Sum of the angles of a triangle A, B and C is always equal to 180 degree, right? So I can write A plus B plus C equals 180 degrees or pi radians, right? A plus B plus C equals pi, so B plus C becomes pi minus A. If I divide this entire expression by 2, I get b plus c by 2 equals pi by 2 minus a by 2. Okay, and the same can be written for a by 2. A by 2 becomes pi by 2 minus b plus c by 2. Okay, so let's just keep this in mind because we are going to use these, this and this. Okay, now as I told you, b plus c by 2 equals pi by 2 minus a by 2. Let me write that down. B plus c by 2 equals pi by 2 minus a by 2. So I can write this b plus c by 2, this b plus c by 2 as pi by 2 minus a by 2. Okay, I get 2 sine of pi by 2 minus a by 2 into cos of b minus c by 2. Okay, and what is sine of pi by 2 minus x? That is cos x, right? So we are going to write that down in the next step, cos a by 2. So this whole thing becomes cos a by 2. This thing cancels out with this. Okay, this is essentially cos of a by 2. Let me write that down again. 2 cos of a by 2 cos of b minus c by 2 upon 2 sine a by 2 cos a by 2. So the cos a by 2's cancel out and the 2's also cancel out. So I'm left with cos of b minus c by 2 upon sine a by 2, right? And also let us keep track of the left hand side. On the left hand side we had, let me check, b plus c by a, right? b plus c by a. Okay, now as in the previous step I can also convert this sine into cos, right? As I told you earlier, a by 2 equals pi by 2 minus b plus c by 2. Okay, if I take the sine on both sides, sine a by 2 becomes sine of pi by 2 minus b plus c by 2. Okay, and what is sine of pi by 2 minus x? That is just cos x. So sine of pi by 2 minus b plus c by 2 will be cos of b plus c by 2. Okay, now I can substitute this right here. Let us do that. Whoops. I have b plus c upon a equals cos b minus c upon 2 upon cos of b plus c upon 2. Okay, now I can do some rearranging. This term is in the denominator, it goes to the numerator on the left hand side, and this a is in the denominator, it goes to the numerator in the right hand side. So I get b plus c into cos of the angles b plus c by 2, which equals a into cos of b minus c by 2. And this is exactly what we had to prove, right? Let me check. B plus c is there, cos of b plus c by 2 is there, a is there, and b minus c by 2 is there. So question solved. Hence proved. Okay, so that does just the trick. This is a neat technique to have up your sleeve, which is to determine which constants are present in the question, rearrange them, and evaluate the expression which comes out of these constants, and then just rearrange whatever you have solved to obtain your final result. Okay, now let us come to strategy number 2. Strategy number 2 is just to evaluate the LHS, the left hand side in the question. So the left hand side is b plus c into cos of b plus c by 2. Okay, now as I determined earlier, b equals k sine b and c equals k sine c, so I can substitute those here and I will get something like k sine b plus k sine c into cos of b plus c by 2. Okay, now the constant k can be taken common from these terms. Taking that common, I get k sine b plus sine c into cos of b plus c by 2. Okay, now again I can apply the sine b plus sine c identity here, which will yield something like 2 sine b plus c by 2 cos of b minus c by 2 into cos of b plus c by 2. Okay, now say I call b plus c by 2 as x, okay, for the time being. Let me call this thing right here x. Okay, I get 2 sine x into whatever this term is into cos of x, okay, because I just said that b plus c by 2 is x. Cos of x. Okay, do you see something here? You have 2 sine x into cos x, and what is 2 sine x into cos x? It is sine 2x, right? Sine 2x equals 2 sine x cos x. Okay, so I can write 2 sine b plus c by 2 into cos b plus c by 2, 2 sine b plus c by 2 cos b plus c by 2 as sine of 2 times b plus c by 2. Okay, because this is x, this becomes 2x, so these 2 in the numerator and the 2 in the denominator cancel out, and what I'm left with sine of b plus c. Okay, so this term and this term, they merge into one term, which becomes sine of b plus c equals k sine of b plus c into cos of b minus c by 2. Okay, now as I mentioned earlier, a plus b plus c, which are again the angles of the triangle, the sum of these angles equals pi radians, okay, or 180 degrees. So you can write b plus c as pi minus a. You can either substitute that here directly, or you can take sine on both sides. Both ways work the same. I'm gonna substitute this right here because I used the taking sine both sides strategy already. So k sine of b plus c is pi minus a into cos of b minus c by 2. Okay, and what is sine of pi minus x? That is just sine x, right? I get k sine a cos b minus c by 2. Now again, as I defined earlier, as I selected earlier, I said a upon sine a equals k, which is some constant, right? So I defined that a equals k sine of capital A. Okay, and what do we have here? This is k sine a. K sine a equals a. Okay, so let me write that down. This gives me a into cos of b minus c by 2, which is just the RHS that I had to prove. Okay, so hence proved. So summarizing this video, you have two methods of solving such questions like these, which contain the sum of the lengths or the ratios of the lengths or just the lengths themselves on both sides of the expression. You can either move the constants around, you can bring b plus c to this side, or you can bring a to the left hand side, and you can generate some ratios of these lengths and you can evaluate that. It will solve itself enough so that once you rearrange the LHS and RHS, you will end up with the answer, which is something we did right here. Right here. And the second and the more conventional way of solving such questions is to just evaluate the left hand side or the right hand side, whichever costs you the least time. But the only way to find which approach will cost you the least time is to actually solve these questions by yourself multiple ways. Okay, so if you like this video, you can show your appreciation by pressing the like button, and if you want to see more such content, you can also consider subscribing. I'll see you next time. Bye bye.